Hi, everyone. Welcome to How to Grow Cannabis 101, an introduction to cultivation. My name is Johnny Burgoon with Prospian. As always, if there are any questions during this talk, you can add them into the question section, and I'll answer those as they go. And if you could add your email, in case I don't get to them, I can respond to you by email. And not to insult anyone's intelligence, but basically I am just introducing the basic life cycle of the cannabis plant and the environments needed to produce the desired results. So we'll move on. As I said, my name is Johnny Burgoon. I've been with Prospian for 10 years. Served most of that time in the cannabis division since coming aboard. I've seen a lot of projects, a lot of different methods of grow, and we're going to talk about those today. So the first thing I'm going to talk about is the cannabis life cycle. There's 4 main steps in this life cycle, but the goal of every cannabis grower is to produce the most terpenes and cannabinoids in their plants. It's important to understand the strain and what makes it thrive to produce the best terpenes for the effect or end product that you're trying to put out. The cannabis plant it's a plant, so naturally it wants to grow, flower, pollinate, seed, and die. We go against nature because we're actually trying to stop the pollination of this flower, which causes the flower to stress and produces more terpenes and a better quality of terpenes. However, great care must be taken to separate male and female plants so that they don't get pollinated. So whenever we're talking about cannabis plants and flowering, it's 90% where we're talking about the female plants that produce the flower. There are 4 main steps in the cannabis life cycle. And we're going to start first talking about propagation. There's 3 main methods of propagation. The first is from seed. This is favored mostly by outdoor producers. It's very similar to what they do in the vegetable, floriculture, farming industry. The great thing about seeds is they can be collected and stored for years after harvest. Seed starting takes 2 days for germination, about 2 weeks to get to a period where they are rooted and big enough to transfer over. It also is about 2 weeks longer than the typical cutting method. Now, the cutting method, that's the very most popular by far. Cuttings are taken from a mother plant with known traits. The great thing about those is that typically when you take a cutting, you're getting the exact duplicate of the plant that you mothered. And the good thing is they enter the veg state almost immediately. A lot of people will take their plants directly from cloning. Once they develop roots, they'll take them right into the vegetative stage. And we're going to talk about these a little further in depth a little bit later. It's going to remain in a 3-week cycle before heading into flower. So it stays in this veg stage for about 3 weeks. And a mother can produce about 10 cuttings per square foot of canopy each week. I saw one of the questions. There's a terrible echo. I don't know if that's me or someone else. Sorry. And the last, of course, is from tissue culture. So tissue culture has been around a long time. It is favored by large-scale producers and very large scale. It's been used in the industries, vegetable and floriculture for years. The great thing is you can make an immense amount of cuttings off of a single leaf. The issue is, it requires a laboratory environment where they take tissue samples from the leaves and put them into petri dishes and propagate them that way. And once they begin to root, you can actually plant them right into media. I wouldn't say the downside, but just one of the things to note is that it takes an additional month to produce a plant clone that way, to the point where it's able to be transferred into the vegetative stage. So those are the 3 types of propagation. Next, we're going to talk about the vegetative stage. So after the plant is either done in a cutting, but basically it's the establishment of roots. roots, it's moved into the vegetative stage. In the veg stage, it'll stay for about roughly 3 weeks, where it's subjected to 16 hours of light and 8 hours of darkness. This puts it into the rapid growth mode. And I put in here paired with a suitable environment, which we'll talk about a lot in depth here in a little bit. But the main environment setting should be held around 70 to 80 degrees and a relative humidity of around 60 to 65%. These are important numbers simply because they're optimal. We have people in regions that grow hotter than that and some that cooler than that. But in general, these are the ideal stages where most of the industry is aiming their target points. Next is the flowering stage, probably the most important stage in the whole process. This is where the plant is basically forced into a flower cycle. It's in this phase for about 9 weeks. And during this 9 weeks, we run about 12 hours of light, 12 hours of complete darkness. And the key term there being complete darkness. Basically, when you cut it to 12 hours of darkness, it forces the plant into the flowering phase. It's super important in this darkness phase that any light leakage at all should be fixed. A small amount of light will cause this plant to hermaphrodite and try to produce pollen, which, again, we talked about that earlier. You're actually trying to stop them from pollinating to put them in distress to produce the best terpenes. So during the flowering stage, the environmental setting should be held around 70 degrees and 55% humidity. That 55% humidity there, which is, different from the vegetative stage, is to ensure that there is no condensation buildup inside the flower bud, which would just produce disease. The last and final stage is the harvest stage. This is where the plant is cut and hung to dry. Now, the goal is to dry them slowly over 7 to 14 days. This helps preserve the flavors and terpenes while it sheds about 80% of its mass in water. So it's basically drying out the leaves, and you're trying to do that slowly so that it preserves the flavor and the terpenes in the products. Kind of been proven that the slower that process happens, the more you maintain the terpene levels and the flavors that are produced by that particular strain. Now, in the dry room, they'll typically hold these plants in there for that 7 to 14 days at 60 degrees, around 55% humidity. And again, that's a pretty low amount, but it's not so low that it's taking so much water out right away. The difference in the harvest stage and the flowering stage is that you're actually not introducing water every day into the harvest stage. So it's strictly just removing water from the plants day in, day out. In the flowering stage, you're watering and adding water to the environment and taking it out every day to maintain that. Here, you're just removing water. You're not watering the plants at this point. You're just taking the moisture content out of the leaves. Thank you. And there's a question popped up: are we going to jump from indoor to outdoor? These apply to both. We do not really talk about outdoor a whole lot, simply because you're subjected to the ambient temperatures and humidities outside. So but the cycle is the same. It's just stretched over a lot longer period. So when you're in an outdoor grow, you can get 1, maybe 2 harvests a year if you're using like an autoflower variety. But mainly it's basically 1 cycle a year, and you're basically limited by the seasons as to when that plant flowers and doesn't flower. So these are mostly, and when we talk indoor, we're talking about greenhouse and indoor grow settings there. Now, we're going to move right into the environment, and I want to talk about all the factors in the environment. So again, getting the best terpenes and cannabinoids are really to talk about the perfect environment needed to spur the best results. And I'm going to talk about those individually. So we're going to talk about the light level first, because all of these are interrelated. So all these environmental aspects that we're going to talk about are really designed towards the indoor grow. And by indoor, I mean in a greenhouse or an indoor. Light levels. So this plant loves light. The goal is to have a DLI of about 40 in 12 hours during the the flower phase. We see customers using 800 to 1,000 U-moles of light, and it's to gain that light level that makes the plant thrive in that environment. Again, you're limiting that light based on what stage it's in, whether it's in veg or flower. And we've seen those get as high as 1,800 U-moles or 80 DLI, but most of the industry is running around that 40 and 12 hours at 800 to 1,000. And different strains have different needs for lighting, or certain growers may have certain aspects they're trying to draw out of the plant. A lot of those are driven by the light and the spectrums of light. It's one of the reasons that the full spectrum LED lights are favored, simply because they cover most of these spectrums. And you can see I've listed the spectrums here. The blue inhibits elongation, important for chlorophyll synthesis, helps greening of seedlings. The green is best for human vision and best for the assessment of plant health, meaning when you're walking in there scouting and things like that. The red speeds up germination, promotes stem growth, important for the flower and fruit production. And then the far red really promotes stem elongation and inhibits some of the branching out. So all of these are included in that full spectrum light. You can have these full spectrum lights basically custom tailored through dimming or through light spectrums directly with the vendor to pick those different types. Next, we're going to talk about temperature, and that optimal temperature being 65 to 80 degrees. It is possible to grow anywhere in that range. But right below that, I have the relative humidity of 55 to 60%. So when we're talking indoors specifically, holding temperature and relative humidity go hand in hand. So I sit back and think about how they're tied together. Typically, if you're running an HVAC system in an indoor grow or a sealed greenhouse method, you're basically, the higher the temperature that you run your facility, the easier it is to draw the water out of that air. The cooler, the harder it is. And it requires an immense amount of tonnage of cooling, a chiller system to remove water at cooler temperatures. So many people play with this like a recipe that they may cook with, simply to play with how much the investment is needed to hold their ideal situation there. But one of the things you need to know is that if you can bear to run your plants a little bit hotter, it's easier to achieve the better humidity. Now, if you're using a vented greenhouse or growing outdoors, you're basically subjected to whatever the ambient is, which changes every day with the weather. But also there's a definitive line in the United States where the humidity drops below this desired 55 degrees and where it increases above that 55 degrees. And that runs north to south, roughly around the Missouri and Illinois border, north to south on the United States. So if you look up a relative humidity map, it'll show you the averages in the U.S. is split pretty much in half, except for coastal areas where it's always humid. But in general, if you're east of that line, you're going to be in an area that the ambient humidity is higher than the desired set points of 55 to 60 degrees. Next, I'm going to talk about air circulation. So whenever you have a sealed environment, you're trying to circulate air. And we talk a lot with growers about having circulation, watching the plants move. And really, we try to achieve a 1 exchange per minute. So you can take the cubic volume of your room and your CFM of your fan and make sure that matches. And that is, so we try to get this 1 exchange per minute of that air in the room. And it may not actually be an exchange where you're exchanging outside air with inside air. It's actually an exchange of just air movement throughout the room within a minute. So it's matching the CFM of circulation to the CFM of your room. And that's just important for airflow so that the humidity you're trying to keep in the room is circulated evenly across the room and there's no microclimates involved there. Now we're going to move right into CO2. So one of the most important things about CO2 is the light level. CO2 really is only used in a sealed environment, like either a sealed greenhouse or an indoor grow. Because if you were in a vented greenhouse that was using outside air, it would just take this CO2 that you're introducing and launch it right out of the greenhouse. So you'd be paying for something you're not really getting the benefit of. But we have seen where CO2 will boost the growth of cannabis about 30% in yield, simply by keeping this 1,200 to 1,500 ppm in this environment. But however, I want to warn you that if you do not have a light level that drives the plant hard, the CO2 will not get consumed by that plant unless they match. So really this 1,200 to 1,500 ppm is really only applicable if you're running this 800 to 1,000 U-moles of light. The more light you give it, the more CO2 you can give it. But I did want everyone to know that ambient outside air is only about 400 ppm. So if you really wanted to improve your yields in a sealed environment, I would increase the CO2 and the light level together along with your water and feeding rates to match that growth. Next, I'm going to talk a little bit about water quality. So a lot of people don't know that in areas where well water is used, that there are changing conditions every year, and a lot of farmlands and places like that contain heavy metals in the water already. And when I'm talking about heavy metals, it's mainly lead, arsenic, and chromium. These are things that are tested regularly in cannabis. And people also need to know that within those water supplies that there are changing conditions as the year goes on. So every year in the spring, there's a lot of fertilizers introduced to the ground, which eventually makes its way to the water table. So you really need to understand and test this water throughout the seasons and years and monitor those changing conditions. Municipal supply is great if you have it. It's already treated water, typically pH neutral, and a very consistent supply. Rainwater, which is becoming more popular. Harvesting of rainwater is legal in some states, but not all. So you need to check with your local people. But all of these come with a certain amount of treatment that has to be done on those. Another thing to consider is your emissions and wastewater treatment. So there are some places that don't allow fertilized water to be just waste pumped into the waste sewer system. So you need to understand those kind of things. And you also need to understand what the post-watering levels of your wastewater is. So you actually want to check your EC and pH after watering, because those are going to be important on how you treat it before you dump it into, either reuse it or dump it into the wastewater treatment system. Next, I'm going to talk a little bit about ROUV treatment. So it's very common that if you have any of these ranging conditions of water supply, that you'll enter some system like reverse osmosis, UV treatment, or activated carbon filtration, which takes care of most of these conditions above. So just be aware that after you get that water test, it's typical for you to develop some sort of filtration system for that water prior to your use, and you definitely want to treat it before you add your nutrients for your plants. And the last is the fertigation water. We call this fertigate. It's basically fertilized water recipes. There are thousands and thousands of growers out there that are using all kinds of different recipes for their fertigation. But in general, everyone starts out with a pH around 6. And this just really affects the solubility of the nutrients you're putting in it. 6 seems to be the magic number with most of our growers. And then what they do is they actually mix in their nutrients and then check for the EC. The EC is the electric conductivity, which is the ability for that plant to soak up those nutrients through that water. So it actually makes the nutrients flow into these plant roots better. So EC in general is the measurement of that electric conductivity, and we have a lot of databases around this, but the averages seem to be about 1.2 to 2 for the flower area, 1.7 for the veg area, and a half to 1.3 for the clone areas. A lot of people like to start out really low with the clones and get them established before they start pushing them with a lot of fertilized water after that. So really following this with the water quality, it's all about your incoming supply, making sure it's treated and the right pH as it comes in, and get it ready for use without other contaminants. And then we'll add the fertilizer until the EC is in the correct ranges before we deliver it to the plants. Now, I'm very, very hesitant to talk about the mixtures and things like that, simply because there are many of these that are just, there's just so many recipes out there for the different things. If anyone has any questions on this, or really, there's a couple questions about yield of cannabinoids, and they vary so much by strain and by different growing methods that I don't want to really put numbers out there. But if you'd like to talk about a specific strain, just drop me an email when you see the introductory slide down here, and I'll get back to you on those. So I know this is very basic, but it basically just walks you through the environment that you need to produce the best terpenes and levels. And again, this is for indoor grow, because outdoor grow, you're specifically at the bay of your weather and the ambient conditions. In the outdoor grow, you can change a few things like shade and things like that, but in general, you're basically at the bay of the weather and the seasons. And then a few of the other things is just to really talk through the life cycle and what happens. And I had a couple questions about wet trim and dry trim in here. And during the harvest stage, there's actually about 3 to 4 steps in there that actually happen before you hang them in the dry room. Some people hang the whole stalks and let them dry out that way after they trim off some of the sugar leaves and things like that. But there's so many different ways of doing that it's really what you're trying to achieve and what your end product might be coming out. And mainly the end product being, are you going to process into an oil or a smokable bud? So there's lots of processes there. But again, our goal today was to really talk about the life cycle of the plant and getting it through those, providing those environmental conditions that produce the best plant. So with that, it's really about it. And as a new grower, you really want to focus on these critical elements being light, atmosphere, and water, because those are going to produce the best terpenes no matter the type of strain. These are about providing a perfect environment. These are plants. Plants prefer an environment where they grow optimally, and that's what our goal here is today, is to help you understand those items. So the light, the atmosphere, the water, those are the 3 most important things to this plant. And with that, that's the end of our presentation. I want to thank everybody. I'm going to answer a few questions here just because I saw a few pop up here. The average yield of cannabinoids, I would really have to understand the strains that you want to talk about there, and the actual, they're measured in a few different ways. So I'd like to understand that question better. If you don't mind dropping me an email. Yes, they grow for flower and oil both. The genetics do make a huge difference. We have customers that are trying different strains of plants to get different yields, faster yields, less powdery mildew, so that it really makes a big thing. Let's see here. DLI is the daily light integral. So it's the amount of daylight you're trying to feed that plant each day. If you'd like, you could look it up online, DLI, and it'll tell you by zone where you're located, what the daily light average is. The cannabis plant itself is a high light plant. So somewhere between 40 and 80 is where you want to learn with that. And what that tells you is whatever the DLI of your particular state or city is, it'll tell you how much light you need to reach the optimal level that the cannabis plant likes. So, and you know, if you want to drop me an email, I can give you a little information on that also, and how we calculate that, and how it's you know, how we calculate that for your specific area and the light level needed to add to reach that desired DLI. And I hope the echo went away. Other than that, that's all the questions we have for today. I'd like to thank everybody for participating today. I know this is a very basic introduction. This is step one of our process, is the introduction. We'll have a lot more of these coming up where we talk about further steps. We'll go into all of those steps a lot deeper, especially lighting. We spend a lot of time on lighting and on HVAC, which we'll talk about those in general. And I say HVAC, it's really dehumidification and temperature that we focus on. And we'll have some more tech sessions later. Thank you, everybody. And like I said, if you have any questions, just drop me an email there and we can get some clarification for you. Thank you.